All right, well, welcome everybody. Thank you so much for delaying your lunch for me and being here. Very glad to have you. We're here today to talk about how to simplify your DBT data pipelines with serverless DuckDB. First, I'll say howdy. Howdy, I'm Alex Monahan. I'm a forward-deployed software engineer here at MotherDuck. MotherDuck is building a cloud data warehouse on top of the open source analytics engine DuckDB. You can think of DuckDB as an amazing single-player experience, and MotherDuck as the cloud multiplayer experience on top. So what are we going to talk about? We're going to start by talking about feedback loops. They mentioned it a little bit in the keynote as well. They're really important. They're how we learn fast. Secondly, we're going to talk about what has changed that allows us to have a totally new paradigm for how to do local development in data. And then we know that we can't run production on our laptop, so we want to have a seamless way to go from local development to cloud production. And we only need to change one config in DBT. And fourth, we'll finally get to that simplifying part. We're going to talk about how one pipeline can own a larger percentage of the data work, so your team can own a larger percentage of the data work. So that way you can get more done without having to double check, triple check with all your stakeholders and go through those feedback loops. Lastly, we'll talk about some other benefits of the MotherDuck architecture and how it really helps your data workflow, your daily job working in data be easier. And we'll save time for your questions. So let's talk about feedback loops. Let's start with an analogy. What makes defining a new business metric so hard and take so long? Is the SQL the hard part? Maybe, but I see a lot of SQL pros in the audience. Maybe the SQL part isn't the hard part. Is it tough to get people to agree? Do we fundamentally believe revenue is something different? Or can we eventually come to consensus? Tell me if you've heard something like this. Can you tweak that for me and bring it back next week so we can review it again? That's the real problem. The problem is that slow feedback loops are what slow us down. And the faster that we can iterate is the faster that we can move our business forward. While we're doing development, that feedback loop looks a lot like DBT build. The speed at which you can run DBT build is the speed at which you can test the hypotheses about your data, you can run actual tests on your data, and you can check to see if your SQL does what you expect. So how can we get this faster? What if I told you that DBT Labs has already published an answer to this, a solution? It's called Shop DuckDB. This is their demo repository for the fastest way to get started using DBT. You can get started in under 1 minute. That's including installing all the Python libraries that you need, downloading and installing DuckDB, and running an entire pipeline, finishing with actually displaying the docs in a browser for you to browse. When I did it on my laptop, it took 35 seconds, so they're not exaggerating. But you might say to me, hey, Alex, but that's a demo project. How do I use that in my real world work? This only has 300 rows of data in it. That's not real world. Let's change that. Let's do more than say hello world. Let's do 30 million rows instead of 300. Let's upgrade our DuckDB to the latest and greatest. And let's use Parquet instead of CSV. It's over a decade old by now. It's a much better way to represent data, especially locally. And let's do it all on my 4-year-old technology M1 Pro MacBook Pro. Let's see how we do. We're going to run our DBT build. How long does it take for us to learn if we did everything right? 4 seconds. That's your feedback loop. That's how fast you can make a change and see the impact. It feels different to do data if you get an answer in 4 seconds. You might say, hey, Alex, 30 million seems arbitrary. How about some more? Let's do 10x more, 300 million. Let's run DBT build again. DuckDB can chew through 300 million rows in 40 seconds. No supercomputer needed. That changes what it feels like to do data. I bet that's a lot faster than your CI/CD workflow. And it's on your laptop. By the way, it's free. You already bought it. Sitting there on your desk, make it work for it. So what has changed? Why is this possible now? Why should we use this as a best practice now when we haven't before? DuckDB has changed it. So you're telling me that a duck made this database? Well, yes. It's named after an actual duck, Wilbur. Come talk to me at the booth if you want to learn more about that. But it's an analytical relational SQL database. So that's a lot of words to say, It's a fundamentally fairly traditional database with cutting-edge research under the hood. It's analytical. It's designed for the bulk transactions you're doing in your dbt pipelines. It's relational. Rows, columns, tables, views, primary key, foreign key. And it's using, I would say, a world-class, world-leading SQL dialect. But I'm a little biased. One key difference is that it's in process. Most databases you think of are running in a separate server process or even on a separate physical server somewhere in the cloud. But DuckDB is running wherever your Python is running, wherever dbt is running. DuckDB is running right inside of it. And that's what makes it a fundamentally single-player experience to use DuckDB with dbt, because it's in that process right next to dbt. It's MIT licensed, so you can build anything with it, commercially or otherwise. And it has 6 million downloads every month and 23,000 GitHub stars. DuckDB is in production at some of the biggest companies on Earth. They went 1.0 in June, and they're ready for production. 3 key takeaways, though. First of all, it's fast. We've seen some numbers. But if it wasn't fast, we wouldn't be here. It's table stakes. It's the bare minimum. It's also got to be easy. If you want to do local development, do you also want to be a DBA on your laptop? You don't. To install and use DuckDB is pip install DuckDB. It'll download a precompiled binary. It's 20 megabytes or so. And it's already ready to go. It has no dependencies whatsoever. Fits into anywhere you're already running dbt. So it's easy. And now, crucially, it can handle larger than RAM problems. Before, your laptop was limited to 16 gigabyte problems, because that's how much RAM you had. But now, you've got 1 to 2 terabytes of SSD space. 16 gigs to 2 terabytes is 2 orders of magnitude bigger problems that you can solve on your laptop. And that feels different. DuckDB itself is also improving at a dramatic pace. So if you haven't looked at DuckDB lately, it's probably a whole lot faster. In the last 3 years, it's over 10 times faster, almost 15. This is using a variation of the h2o.ai benchmark with some window functions added and some import and export added. So it's not just getting faster at the group bys and joins you care about. It's also the import and export speed. All aspects of the data workflow are getting faster with DuckDB. That's the software side. Let's look at the hardware side. Since dbt launched in 2016, MacBook Pros are 5 times faster. That's a big deal. They're about to launch the M4. It'll be another 25% boost if you believe the rumors. That means it adds up to 600 or 700% faster than 2016. It's a different world that we live in. Let's take advantage. If you put it all together, DuckDB software, modern hardware, how does it actually shake out versus a cloud data warehouse? George Fraser, the CEO of Fivetran, did a benchmark. And DuckDB running on his laptop was compared against a 16-core data warehouse from Database X. And DuckDB was faster. And that's in 2023. Since then, your MacBook Pro is 70% faster. It's about to get faster than that. And DuckDB is 800% faster since then. So disclaimer, it is a different benchmark. It is not apples to apples. But the order of magnitude is the same. It is way faster, even than just 2023. How about the server side? Since 2010, one server is now as powerful as 3,000 of them from 2010. So why did I pick 2010? 2010 is when the current generation of cloud data warehouses were being designed. It was when the Dremel paper was published by Google. And they formed the foundation of how every cloud data warehouse today was created. And at that time, server CPUs had 1 core. Turns out today you can rent some with 400 cores for $11 an hour on AWS. The world is different. How do we take advantage and make our lives easier as data people? So what didn't change? If the big data explosion we were promised actually happened, all that hardware wouldn't have even been able to keep up. But it turns out that big data was mostly marketing. And I want to make the case to you with actual data. We're going to look at a treasure trove of data that our friends at Amazon from AWS published. They published a paper on why the TPC benchmarks are not enough for true database performance. You need to look at real queries. So they published a data set of 500 million of them, 500 million queries on 32 million tables, 3 months worth of queries on Redshift. Let's see if we can find any big data on a cloud data warehouse running in production. So we believe that big data is dead. That's our marketing term that big data was mostly marketing. We believe three fundamental things about this: that most people don't actually have big data. And that's okay. You can run a business optimally with small data. Turns out you might not need that big data. Secondly, we believe that even if you have big data, you're not using it all the time. You're probably pre-aggregating it, using something, I don't know, maybe a three-letter acronym. Maybe it's DBT. And then, even if you are going to access that large table, you're not going to do select star from giant table. That'd be crazy. You're not going to read it all at once. You're going to read it in chunks. You're going to read only the data that you actually care about, your hot data. So how do these prove out in the actual data? From Amazon, not from us. 95% of databases are less than 10 terabytes. That's our cutoff for what we're calling big data with these numbers. 95% of the time, people don't have big data. Well, I think our tenet number one holds true. How about our second one? For those users that had big data, 99% of their queries didn't even access that big data. They accessed all the aggregate tables. And then when those users, that 1% of the time that they accessed the big table, 99.9% of the time, they only read a less than big data amount of that big data table. So let's do some back of the envelope math. 5% of the time you actually have big data. 1% of the time you actually look at it. And then when you look at it, 0.5% of the time you look at all of it. That is 0.00025% of the time. That's 1 in 4,000 that you actually want to access big data. Why are our systems designed for the 1 in 4,000 and not for the 3,999 other queries? Maybe we can be more efficient. Maybe we can be faster. So we talked about local development. We talked about how servers have changed. We need both. How do we seamlessly go back and forth? In the data world, we know that there's a lot more to running in production than local development. You need to integrate with the ecosystem. We like to call this the modern duck stack here at MotherDuck. We like our puns. We've got a variety of ingestion tools, Fivetran, Airbyte, many others. DBT, of course, for transformation. A variety of business intelligence tools, data science tools. And you can also orchestrate and maintain your data quality. But you can't do that off a laptop. You really need both. You need a cloud data warehouse that works with all the other tools you're already using. So we've talked about it a lot. Let's do a formal definition. What would we define MotherDuck as? We are a serverless cloud data warehouse. We're built on open source DuckDB, and we're fundamentally higher efficiency, lower cost, easier to use, lower friction. But by the way, we can still scale to the size of problems that you actually have in your business. We are now generally available. We launched in June. When we were here at Coalesce last year, we were in beta, and we get to be here running fully in production for multiple months. We call ourselves the Ducking Simple Data Warehouse. There's more puns. Let's look briefly at our architecture. To connect to MotherDuck is the same way you connect to DuckDB. We are an extension. So all you do is change your connection string to start with MD:, and any existing DuckDB client will auto-download our extension and form a bridge between your DuckDB locally and our DuckDB in the cloud. It works in Python with dbt DuckDB. It works on our command line tool, Java, if you want to use dbeaver or datagrip, your favorite IDEs. It even works in the browser with WebAssembly. The MotherDuck web UI is built entirely in the browser. Once you connect, once that extension's been downloaded, you enter our control plane, where we can handle security and access controls and route you directly to some compute. And you, as an individual user, are going to get routed to your own individual compute. One user gets their own individual powerhouse compute instance. And the connection is direct, so you're not doing multiple hops. We've also completely re-architected the storage side. DuckDB is a single file format like SQLite. All your tables, all your rows all fit into one file. And that's really great if you want to email it to somebody. But it's not great if you want to do it in cloud object storage, because you have to rewrite the file every time. So we have an incremental storage system built on top of the DuckDB file format. So it's fully compatible and optimized with the cloud. Sounds great. How do I move back and forth? Local to cloud. Change one config. In your profiles.yaml file in dbt, add a new output, type prod, and just change your path. md:/mydb, any database name you'd like. The SQL is exactly the same. There's no transpilation happening. It's the exact same SQL locally as in the cloud. So you can run all your tests locally, and when they pass, you can be confident that they'll also pass in the cloud in production. One config is all it takes. So let's simplify those pipelines. Now that we have both local and cloud, how can we simplify our data workflow? We sometimes call this the revenge of ETL, if you will. In this case, we as our team, our data team, can own the entire process all in one pipeline, so we can have a faster iteration and feedback loop. One git commit can change this entire workflow. You can add a column everywhere in one shot. So where can we pull from? DuckDB can pull from all over the place. All three clouds, object stores, all the various formats you want, JSON, Parquet, DuckDB, CSV if you have to. We'll do it. You could pull from Iceberg and Delta Lake as well. So we do support those lakehouse formats. We can even pull from your operational data stores directly. We can query Postgres and MySQL without any previous extraction. So you can query straight from, hopefully, a replica of your production system. So it can all be in the same workflow. Next, we're going to do some transformation. And we're going to do this on the local DuckDB. But I'd like to stretch the definition of local. This is wherever dbt is running is local. It could be your laptop while you're testing, but it's probably your orchestrator, Dagster, Airflow, Prefect, or GitHub Actions even, which is a simple orchestrator. And you can do transformations and tests right there before you even put it in the cloud. You could deduplicate. You could sessionize, have some complex window functions to see how long was my customer actually logged in, right? Plenty of transformations you want to do just on new data, you can do just on new data before you even upload it. And you can test it. So if your tests fail, you didn't spend any cloud dollars. Now you can insert it. And to upload it to MotherDuck is as simple as an insert statement. Because we automatically have that bridge formed, so dbt can control the ingest as well, all the way up to the cloud. The rest of your dbt pipeline can do all the transformations on your full data set in MotherDuck in the cloud. And for bonus points, if you're using a BI as code tool, that same commit, that same repo that added a column in your source system can bring it all the way through to your BI tool so your stakeholders can see it in one commit that your team owns, that you didn't have to go ask anybody about. You just did it. You're done in an hour. The MotherDuck architecture has other benefits for you and your team. In the post-big data era, as we like to call it, scaling up actually provides better performance at the scale of data that we actually use. With MotherDuck, we talked about how we give you a direct connection to your own big, beefy server instance. That means you have less than 200 milliseconds of latency to work with us. We've actually done some recent tests where now it can be as low as 50 milliseconds. So the slides are already out of date. Imagine that on another data warehouse. In contrast, the legacy data warehouses are chained to that 2010 architecture. You're going to hit a load balancer. It's going to communicate with a pool of workers. They're going to split up the task and schedule it. They're going to have to talk amongst themselves and shuffle, and each work on a different piece of it, and then finally roll up the data, bring it back through the load balancer and back to you. Every shuffle, every network hop is expensive, both in time and in money. So why do they still have this architecture? Well, they were designed when servers had one core. And they are still chaining themselves to the idea that it's still a good idea to query a petabyte at the same time. If you free yourself from those two constraints, and if you were designing a new system today, like we are at MotherDuck, you'd use a simpler architecture. You would scale up and have that much lower latency. So on the queries you're actually running, on the sizes of data you actually have, the result is better performance. So now, with apologies to Liberty Mutual, I mean Liberty Birdie, only pay for what you need. So what do I mean by that? MotherDuck is serverless. If you're doing that magical local development, you don't want to be paying for a cloud instance that's running the whole time. What we do is we charge you based on the actual CPU use you use every second. We charge you storage by day. So it's great if you've got daily batch jobs where you need a lot of compute for a little while, but then sporadic BI use throughout the day. A lot of workloads you see in a traditional data team. This makes us dramatically more efficient. So if you look at that diagram, this is the compute resources for one query. If you're using an incumbent data warehouse, you have to size for peak. You have to size up extra because it can't scale up dynamically on demand. So you're paying for extra, more than you need. And then when your query is done, it's going to stay idle for a little while it's shutting down, and you're going to pay for that. Whereas with MotherDuck, we charge you for the area under the curve, only the CPU use you actually use. Dramatically more efficient. In conclusion, the combination of DuckDB and MotherDuck changed the game. I like to call this magical modern data. dbt, DuckDB, and MotherDuck. The combination of DuckDB and modern hardware means that our local development workflow can be magical. Let's go all the way back to that initial example at the beginning. You sat down with a stakeholder. They said, can you tweak that for me and bring it back next week? Instead, you say, I'll tweak it for you right now, and let's look at it in 10 seconds. And then they look at it and say, oh, wow, interesting. Can you tweak this other thing for me? And you say, you bet. 10 more seconds, they have the answer they want. You save 2 weeks of cycle time on your process, and your business is going to run better because now you're making better decisions weeks in advance. And how much happier is your team going to be? Secondly, once you have that magical local experience, you need to run it in production. It needs to integrate with all the tools your stakeholders are using, your BI platforms, your observability systems. It takes one config change in dbt to push from local to cloud, as easy as that. And lastly, using one big beefy node per user is the best way to achieve low cost and low latency, which actually today, with the sizes of data we saw that get used on Redshift, that means actually better performance. It's the right way to build a system for the modern post-big data era. So thank you very much for your time and attention. Please stop by the MotherDuck booth, but we do have some time for your questions. I saw you first.
Does the in-process DuckDB support multi-threaded Python application?
It does, yes. So the question was, does DuckDB in process support multi-threaded Python applications? And the answer is yes. They have full multi-version concurrency control, much like Postgres, other cloud data warehouses, where they use snapshot isolation to only read the data that's been committed. And so multiple threads work well. The key difference is multi-process. You can't have multiple writer processes with DuckDB, whereas with MotherDuck, we make that possible. You know, there might be a Docker image, but DuckDB is so simple, we don't even recommend using Docker. It is one binary. I mean, you can copy paste it wherever you'd like, really. But I'm sure we can find one for you. I'm sure there's a way. Yeah, we can make that happen. Yes?
I'm not sure if I saw Fivetran on your architecture slide.
You did.
Okay. Are you integrated with Fivetran?
Yes.
Okay.
We'll keep that slide up. There's a lot of small font in there. Yes, Fivetran is conveniently at the top of the list. Great question. Yes?
Are there any plans to support exporting to Iceberg?
So writing to Iceberg is something we're excited about. You know, I follow the space closely. We follow it closely. Outside of Java, that's not really something that really happens today. It's really locked into the Java ecosystem. We're working on it. Thank you. Yes?
Sort of a backwards question. Are there any use cases you think of that DuckDB and MotherDuck would not be a good solution?
Sure. I think we don't believe that there's one database to rule them all. I don't think any database truly believes that. I think there's definitely use cases where, you know, if you do actually have to do a big batch transformation of a huge historical data set, it's probably best to do that with another tool that's just for batch, where that extra latency isn't so bad. Maybe you do that, but then if you landed in something like Iceberg on Object Store, all your consumption can flow through MotherDuck. So we do work really well if you wanted to have something else for that really giant batch use case. We also don't do streaming. I think micro batch works for us. So we think we can do quite a lot with microbatch. But if you really care about that individual row at that 10 millisecond latency, you probably want a streaming tool. Yes?
With what you mentioned about the link between local and cloud, like using MotherDuck, how does that work then with like your sources and your source tables? So are you saying that everything you should just land it in S3 or some kind of cloud source so you can always be reading from Parquet, or does that link handle here's where the source tags are coming from, it'll download a local copy from MotherDuck, and then do all the transformations locally?
That's a great question. I'll move us back to that other diagram. We could chat about it. But that's a great question. In general, I didn't talk too much about it, but when we form that connection, we actually can choose within one SQL query to run part of your query locally and part of it remotely. And we look at mostly where your data lives. So if you're doing, like this diagram was more of an upload process, where you're bringing data in, the data may be more local already. But if it's already in the cloud, say you're in an object store, you can actually refer to it directly in the MotherDuck side, and we'll route to the right compute that's closest to the data. In terms of just the process of choosing which of those to do, you kind of have full choice as a user to decide, do I want to do my processing locally or in the cloud? And there's a lot of ways to mix and match that workflow as well. Does that help? Or?
Yeah. So just to kind of make sure cover, so it really, like if you were setting up locally, it's like obviously you have nothing, right? You haven't set up the local thing the first time.
Mm-hmm.
Like, okay, let me pull where it's at, and then the back end's going to be running, and this may not update or refresh it from this raw table.
Sure. The way that it works for us, we don't store a persistent copy of your data locally. We're kind of an ephemeral cache, but you can choose to persist it and kind of build your own cache if you'd like. So a local workflow that we envision as well is, let's say you have a data set that you know you're going to be working on for the next 2 weeks. So maybe step one is I go ahead and I set up an incremental load for that, but I do an incremental load to Parquet on my laptop. And suddenly, the first day, before my lunch break, I click go, and for an hour, I'm downloading Parquet files. And then every subsequent time I'm using it, I get instant feedback that whole day. Then maybe the next day I run it, just download 1 day's worth, so I have a 5-minute coffee break before my job gets going, and then I get instant feedback loops the whole time I'm doing active development. So incrementally loading to your laptop is a pattern that is viable now, I think. Thank you very much. Other questions? I think I saw you first.
I have a comment on that analytical relational database. That feels like a very bold statement. I'm looking forward to reading a little bit more about that. That sounds very interesting. My question is regarding development, collaboration, and local development. So for example, our setup right now is we're in Snowflake. Every person basically has a full copy of production through clones, and we're able to collaborate very easily with each other. How would that work through if you're taking advantage of your local compute, your laptop? How does collaboration happen in the development? I guess in that pre-production part.
Sure, that's a great question. So his question was, how do you do collaboration while you're doing local development? So the first thing is that we also support a zero-copy clone operation in the cloud. So because we have that cloud-optimized storage layout, you can do the same zero-copy clone that you're accustomed to in Snowflake and have your own dev branch while you're doing your work. And so you can use the exact workflow you use today. If you want to additionally layer on the local development workflow, so maybe before you would commit your PR and push it, maybe you do some local commits before you push. It's that same sort of mentality. You could do those kind of local commits really, really quickly locally. When you want to publish it to your team for their feedback, you would kind of do that push and push to the cloud. Great question. Yes?
In MotherDuck, are users and permissions similar to something like Postgres?
Great question. The question is around users and permissions. So we're actively adding a lot more here. DuckDB, by its very nature, is in process, so it can see all of your memory. There's no hiding. So it doesn't have an access control layer in DuckDB because it doesn't need it. So we're adding that in MotherDuck. We already have access controls at the database level, and we're adding more in the future to get more granular with that. But that's a key differentiator for us as MotherDuck, is to have that layer of access control because you need that to run in production. Yes?
In MotherDuck, how do you secure data at rest? Snowflake has their way, we try secret. How do you guys do it? So my data is safe if it's PII or REST?
Yes, absolutely. I mean, we're SOC 2 certified. We're in the pursuit of our SOC 2 Type 2. We take it very seriously, to have secure data. We do encrypt at rest. I can get you more details at the booth. Thank you.
What is a typical migration from the accounting data warehouses to
Sure. I think the question was, what does a migration typically look like? I think with these new table lakehouse formats, it gives a really smooth path where suddenly you can share Iceberg as the common denominator across all your systems. It makes transitions way easier. So that'd be probably our main recommendation is if your system supports exporting to Iceberg, we support reading from Iceberg. So that's a really excellent bridge. And DBT said the sales pitch better than I could about that too. So that'd be our first thought. Other questions?
So along that line, is it incumbent on you to make all of your models incremental if they're not?
The question was, is it incumbent on you to make your models incremental? I think you mean to take advantage of Iceberg?
I guess, yeah.
You know, you can choose. I think it's always a best practice, I think, to do incremental, but we don't require it for sure. Stop by the booth. We've got some other DBT experts as well. We can help you in your case. Other questions? All right. Thanks very much. See you at the booth.